Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to look at how to multiply polynomials together. Last lesson we learned how to add and subtract them, so now we're going to add in another operation, and that is multiplication. To start off, and again, this is something we've already done actually, so you just haven't done it as intensely as we're going to do it today, but you have kind of broken the surface of what we're about to do. So let's start off with the do now. Again, this is something you've already done. And I want you to simplify the following expressions. So think about what type of multiplication needs to occur here, how do we do it, and then write down what you get. Pause the video and then come back and check your answers. Okay, so, and this gives away the answer down below, but we need to use the distributive property here. We need to multiply the 4 to each term inside the set of parentheses. So we get 4 times x, which is 4x, 4 times negative 6, so negative 24. 4x minus 24. Same thing over here. Negative x times 5 gives me negative 5x. Again, we write the number before the variable in a term that has both numbers and variables. Then I have negative x times x squared. Now, this gives me negative x cubed. Because remember, the exponent on the x is just 1. And when I'm adding two bases that are the same, when I'm multiplying two bases that are the same, I am adding the exponents together. So 1 plus 2 gives me 3. I did say that I gave away this answer down below. What property did we need to employ for the do now problems? That was the distributive property. All right, we're going to go through 3 examples, I believe. 1, 2, 3, and then those should help you complete the rest of the problems in this packet. So we're just essentially extrapolating on what we did in the do now. We're just making it more complicated. But the distributive property is going to stay the same. Now, if we start with this one, this is a monomial by a, should say trinomial. Well, it's fixed on your paper. Let me fix it on mine real quick. Monomial multiplied by a trinomial, trinomial meaning 3 terms. We did a monomial by a binomial up above. So I'm still just going to distribute. I'm just going to distribute 3 different times. So I'm going to get negative 6x squared times x squared. That gives me negative 6 x to the 4th, adding the exponents. Negative 6 times negative 2x gives me positive 12 x cubed. Multiply the numbers together, and then to figure out the variable portion, we're just adding the exponents, and there's a 1 on this x. Then I get negative 6x squared times 9, which gives me negative 54x squared. And this isn't standard form because the degrees are decreasing. We go from 4 to 3 to 2. Pretty straightforward, right? We're just adding that extra term that we're distributing to. Let's go ahead and try one that looks a little different. So now we're going to multiply a binomial by a binomial. Distributive property still holds. We just have some more distributing to do. I'm going to start with my 3x distributed to my 4x and my 5. That gives me 12x squared. X times x is x squared. 3x times 5 is 15x. Now, the second part of this is we also have to distribute this negative 2 to both the 4x and the 5. I just like drawing my arrows underneath because there's more space there, but again, you could just draw yours up above as well. Doesn't matter, as long as you know that you have to distribute the negative 2 to both the 4x and the 5. Now, please don't forget this negative sign. Right, this negative sign goes with the 2, so we got to include it every time we multiply. So I'm going to get negative 8x minus 10. Now you may be tempted to just box up your answer and call it a day, but we're not done simplifying yet. This is not in standard form because we have not combined all the like terms that are possible. Right, we can combine these two middle terms. to get 12x squared plus 7x, 15x minus 8x is 7x, minus 10. Now we have an answer that is in standard form. So if you have two terms in your first set of parentheses, that just means you have to multiply each of those to the second set of parentheses. But it's the same idea, you're just doing it twice. Let's look at one more example. Here we have a binomial by a trinomial, and we're actually multiplying the trinomial to the binomial, but again, just one of each. Now, you can choose to do this in whatever way you want, right? If you really wanted to, you could just put the 11m minus 2 on this side and do it that way, right? If you wanted to, you could just get rid of, see if I can do this. Because you're multiplying, it doesn't matter what order. So if you wanted to do it like that, you could, but we'll do it the way that it was set up. Now, most of you probably see what we're going to do here. I'm going to first distribute, let's make that a little less heavy. So I'm going to distribute the m squared to both first. So I'm going to get 11m cubed minus 2m squared. Then I'm going to distribute the 3m to both. So that's going to give me plus 33m squared minus 6m. And then you're going to distribute the negative 5 to both. So on these, you're going to have to put two of those sets of arrows either on top or on bottom, either way. Again, it doesn't matter if you actually have the little arrow on the end, you get the idea. Those are just showing you what you need to multiply. And technically, you don't even need the arrows, right? I just put the arrows because it helps us not forget any step of the multiplication process. What I found is that students who don't draw the arrows tend to forget, certain parts of the multiplication, so their answer isn't complete, right? So just draw your arrows. That'll let you know how many terms you need down below. In this case, we have 6 arrows, so we're going to have 6 terms, at least before we simplify. This is going to give me negative 55m plus 10. Again, you may be tempted to stop, but we need to combine our like terms. Well, there's only one m cubed, so I'm going to keep it there, 11m cubed. I have 2 m squareds, though. So that's going to give me plus 31m squared. I have 2 m terms. Combining those is going to give me minus 61m. And then I just have a 10 on the end. So plus 10. There's no other numbers to combine. So right here, that is our answer in standard form. 11m cubed plus 31m squared minus 61m plus 10. So again, today is all about distributing. And all we've done is stretch out that process. We're just doing it more times than we're used to. But it's still just distributing. So there are plenty of problems for you to practice. We're not going to do any of these because we've done 3 examples. They should help you with all of these problems. We are going to go down to, we're actually going to go down to the very last problem here. So it says a smartphone has a screen that has a width of x and a height that is 1.8 times the width. The outer dimensions of the phone are shown. We need to write an expression for the portion of the phone that is not occupied by the screen. Assume the phone is rectangular. Okay, so it gives us the dimensions of the entire phone. What we need to find is an expression for the portion of the phone that is not occupied by the screen. So we're actually looking for, let me just shade this. It's this pink area right here. And it actually goes all the way around the phone. There's a little bit less of it on the sides as there are on the ends, but there is a sliver on all the sides. So we need to subtract out the area of the screen from the entire phone. That would leave us the pink area. Well, we need to figure out what's the area of the screen. I know the area of the whole phone, right? 1.8x plus 3 times x plus 1. So let me just start writing this down. Area of the whole minus area of the screen. Well, that should give us the area of the pink. So an expression for the area of the whole phone, right? Well, length times width. So that's going to be 1.8x plus 3 times the quantity x plus 1 minus the area of the screen. Now, here's the thing. The screen is not labeled dimensions-wise on here, so we have to do that ourselves. We are told that the screen has a width of x. So essentially, this is x, and it has a height that is 1.8 times the width. And this is a little confusing because the phone is actually tilted on its side, but if it was, tilted straight up, this would be the height right here. And that height is 1.8x. So you can see that the extra room on this dimension is 1 centimeter. So a little bit on either side makes up that 1 centimeter. On this dimension, whether you want to call that the height or the length, that is the extra space there is 3 centimeters. So there's obviously a little bit more on the top and the bottom of the phone than there are on the left and right sides. Again, if we were thinking of the phone standing up. So I'm just going to multiply the length and the width for, we'll call this the green. So we'll just shade this in green. That's the screen. So the area of the screen, right, well, that's going to be 1.8x times x. That will give me the area of the pink. So a couple things to do here, right? You've got one distributing portion of this problem. We have a binomial times a binomial. Then you have a monomial times a monomial, 1.8x times x. And then you're going to have to combine your like terms, right? You're subtracting one from the other. So pause the video, go ahead, simplify the left-hand side of this equation to see what you are left with in pink. All right, what I am going to do is try to move this up for us. So we have some room to maneuver with. Okay, let's move the page up. A little too far. There we go. That'll do. OCD is getting the better of me right now. Okay, there we go. That'll be a little better. Okay, so if I simplify the orange, right, if I do my distributing, I'm going to get 1.8x squared plus 1.8. Then I've got to distribute the 3. That's going to give me plus 3x plus 3. 1.8x times x, 1.8x squared. Of course, this stays the same. I can start simplifying like terms. This 1.8x squared and negative 1.8x squared, those simplify each other out to 0. My x term, I only have one of those, so I get 3x. And my two number terms, 1.8 and 3, so I get 3x plus 4.8. That is the area of the pink, or that's at least the expression that represents the area of the pink. So there we go, applying polynomials to a word problem. That's going to do it for today. As always, enjoy the rest of your day, and we will look forward to seeing you next time, where we look at some special types of multiplication of polynomials.